A hyperbola is the set of all points in a plane, the difference of whose distance from two fixed points f1 and f2 is constant. These two fixed points are the focus of the hyperbola. So the hyperbola are of the equation of x squared divided by a squared minus y squared divided by b squared equal 1, where here in this case that a greater than b greater than 0 is have the vertices of a0 and negative a0. The transverse axis is have the horizontal length of 2a, the asymptote of y equal plus or minus b over a x. The focus is x squared, c squared equal a squared plus b squared. Now the hyperbola open either horizontally or vertically. So one of the easiest to remember is if you have an x subtract y, then it is open horizontally. But if you have y minus x, then it's open vertically. Okay. So let's take a look at this. Find the vertices, focus, and asymptote of the hyperbola. Determine the length of the transverse axis and sketch the graph of the hyperbola. So here we have to put the equation into the standard form. So I go ahead and divide everything by 36. So then I get x squared divided by 4 minus y squared divided by 9 equal 1. So here, because we have x squared minus y squared, we have this hyperbola is open horizontally. So the vertice is the a, right? The vertice is a. So the vertice in this case are plus or minus 2a. Excuse me, plus or minus 2, 0. So we have 2 points plus or minus 2. Okay. The focus c squared is equal to a squared plus b squared. So that is 4 plus 9 equal 13. So the focus are plus or minus square root 13, 0. So these are the points that is inside the hyperbola. Okay. And the asymptote y equal plus or minus b divided by ax. So that equal plus or minus 3 over 2x. So let's go ahead and put in the two asymptotes. So if the first asymptote y equal 3 over 2x, which means it have the slope 3 over 2. So go up 3 over 2. Go down 3 over 2. So here you are looking at the asymptote. This line. That one asymptote. The other asymptote y equal negative 3 over 2x. So it have the slope of negative. So here's the first point. Here's the second point. We can draw the asymptote. The focus is root 13, so that is between 3 and 4. So these are the focus. F1, F2, okay, and this is the hyperbola. The length of the transverse axis, equal to 2a, and that is 4. The next example, here we have y minus x. This means the hyperbola is open up and down. Right? So here we have a equal to 4 and b equal to 3. The focus x squared, c squared is equal to b squared plus a squared equal to 13. So c equal to plus minus root 13. Now because of the hyperbola open up and down, the focus is lie on the y-axis. So the focus are 0 plus minus root 13. The vertices are 0, 4 and 0, negative 4. So first vertex, second vertex, b squared plus a squared, that's 16 plus 9, that's 25. So c equal plus or minus 5. So the two focus are plus or minus 5 on the y-axis. So here the focus 1, here's the focus 2, and here's the vertex. Okay, and the asymptote y equal to a divided by b. So that is 4 over 3 plus minus x. So the asymptote, so go up 4, 1, 2, 3, 4 over 3. And again to the other side. This is our first asymptote. And here our second asymptote. The hyperbola going up and down, passing through the vertices. The length of the transversal here is 8. Let's say we want to find the equation of a hyperbola that satisfies the given condition. We have the vertices plus minus 3 and focus of plus minus 4. Now because of the vertices on the x-axis, this means we have the case of x squared divided by a squared minus y squared divided by b squared equal 1. Okay, so here we know that a is equal 3. This telling us that a squared equal 9. We are given c equal 4. Absolute value of c equal 4. And we know that c squared is equal to a squared plus b squared. So then b squared equal to c squared minus a squared. And that is 16 minus 9 equal to 7. So b squared equal to 7. Then our equation for the hyperbola in this case is x squared divided by 9 minus y squared divided by 7 equal 1. Okay. If we have the vertices equal plus minus 0 and the asymptote y equal plus minus 5 over x, it's still the same form of x squared over a squared minus y squared over b squared equal 1. And we are given here an absolute value of a equal 1. This means a squared is equal 1. Well, the asymptote is of the form of y equal plus or minus b divided by a, x. If a equal 1, then we have y equal 5 plus minus 5x over 1. So then b is equal 5. So b squared is 25. Then we come up with the equation x squared over 1 minus y squared over 25 equal 1. The next case, we have the focus is on the y-axis, then the hyperbola also passed to the point of 1, 4. So we are looking for the hyperbola of the form x squared. We're looking for the hyperbola of the form of y squared over a squared minus x squared over b squared equal 1. We know that c squared equal to a squared plus b squared, and that equal to 9. Okay, and the hyperbola is passing through that 1.14. So let's see if we can come up with an equation and solve this. If a squared plus b squared equal 9, this means a squared is equal to b squared, equal 9 minus b squared. I will go ahead and substitute this into my standard equation. So this means y squared over 9 minus b squared minus x squared divided by b squared equal 1. And if this hyperbola passing through the point 1, 4, I know the value of x and I know the value of y. I can plug this into the equation. So 4 squared divided by 9 minus b squared minus 1 squared divided by b squared equal 1. I can solve this equation for b as follows. We combine like term. And factor. So this means b squared equal 1. Now that I get b squared equal 1, I can solve for a. I know a squared is equal to 9 minus b squared. So a squared equal 8. Then the equation of the hyperbola become y squared divided by 1 minus x squared, y squared divided by 8 minus x squared divided by 1 equal 1.